3D printing is a generic term that's used to describe a whole series of additive manufacturing processes, which are distinct from subtractive processes, where you take a piece of material and remove it to make the object you want, or formative, where you squish together the material into a new shape. Additive is about, just as it describes, you add layers of material, one layer at a time, to build up the object that you want. So what's revolutionary about 3D printing is the way in which it does not require the use of any tools or molds. So this is typically quite a big constraint on the production process because tools and molds are very expensive, slow to make. And once you've got them, you want to use them a lot to produce lots of the same product exactly the same. With 3D printing, you have the potential, with no molds and no tools, to produce exactly what you want in units of potentially just one. And the way it does this is by using a range of materials, so plastics and metals and ceramics. And typically this is provided in powder form, or in the case of some materials in liquid form, and you selectively apply energy to solidify it just where you want it to be formed. And you do this layer by layer to build up the object. So unfortunately, people have got very, very excited about this. So although the technologies have been around for the last 20 years, various things have happened recently that have created this dream of what some people are calling the Santa Claus machine, the machine you could have at home that would make anything you wanted. However, being around for 20 years, the technology has been deployed in several areas that are very interesting. So the development of rapid prototyping is a well-established technology now. The area of rapid tooling has also emerged and is being deployed in certain sectors. But what's particularly exciting at the moment is the production of finished products. So the final product is produced using 3D printer technology. So I think there are three areas where 3D printing is being used in quite an exciting way and almost revolutionary. And that is in the field of healthcare, where we see the development of low-cost prosthetics, particularly targeted at children and at developing countries. We see the advent of lots of very exciting applications of it for implants and for surgeons to both build models before they actually conduct surgery, but also for the actual part they may be inserting into the body to replace a broken part, for example, a smashed jaw or a missing cheekbone, something like that. But we're also seeing exciting things around the possibility of its use in personalised medicine, so the local production of pharmaceuticals. We see another interesting area around spare parts. So there's much excitement at the moment, and you see stories around the use of 3D printers in space, which sounds like a bit of a gimmick, but actually has great potential, because if you're in the space station or on your mission to Mars and some small component breaks, it is unlikely you'll have enough spare parts for that particular component, so why not produce the spare part where you need it? This is also seen in the world of defence, where you want to have spare parts made very, very close to where they're needed, rather than having lots of high-risk, long supply chains. So the Bit-by-Bit project is an ESRC and EPSRC-funded project here at the University of Cambridge Institute for Manufacturing. And what it's trying to do is to connect all the issues to do with technology, and issues to do with economics, and issues to do with policy, regulation and law. Because at the moment, much of the debate around 3D printing is a bit polarised. There's great work being done around the technology side, around the legal side, around the economic side of it, but these aren't necessarily connected. So one of the things we're trying to do is to have a project that brings together experts from those three fields to help us understand what the potential of 3D printing really is. So there are a lot of exciting things that 3D printing might be able to do. But what we need to do is not consider these as technical problems. There's lots of technical problems still to be overcome, but they're not exclusively about the technology. What we must do is connect the technology issues with the economic and social issues, with the policy, regulatory and legal issues.